This is Euclid Book 5, definition number 3. Okay? Once again, getting you to visualize what you're doing. It's more important to visualize it than it is to actually say it. Okay? Now we're going to talk about ratios. Let's go back to A and B right here. Alright? A ratio is a sort of relation. These two are related to each other. Why? Because this is a part of this. Do you remember that from the last video? If you don't, go back to the last video and watch it again, then come back here. This is a part of this. Okay? Now, a ratio is a sort of relation in respect to size. Okay? This is smaller to the bigger. Okay? Between two magnitudes, well, this is magnitude number 1, which is called A. This is magnitude A, and this is magnitude B. Okay? Now, these are line magnitudes. Okay, so a ratio is a sort of relation in respect of size between two magnitudes of the same kind. So, these are both lines. They're also both magnitudes. Okay? But these are line magnitudes. In Book 6, which we have not yet covered, and we will, in Book 6 it will say, okay, you have a short line to a big line, and then you have a small triangle to a big triangle. Okay? So the relation will be, inasmuch as we've increased the size of the little line to the big line, we're also going to increase the size of the little triangle to the big triangle. Okay, so if, let's say we have two lines, like here, A and B. We already said in a previous video that A is 1 inch, B is 2 inch. We've actually doubled the size of A to make it B. In the same manner, we would take a triangle, a very small triangle, and we would literally double its size. So, the ratio of A to B, which are the lines, would be the same ratio of triangle A to triangle B. Okay? Now, when you're having a ratio of two lines to two triangles, then you have a mixed ratio. We don't want mixed ratios in the beginning of this. Okay? So, Euclid's saying that we have regular ratios, and then we'll later on have mixed ratios. Okay? And we'll talk about mixed ratios later. Right now, in Book 5, we have regular ratios. The only way these ratios work is if we're dealing with lines. 1, 2. Okay, we have line A, we have line B. So what we'll do is we'll have this entire discussion. We'll have an A, a B, a C, and a D. But all four of them will be lines. Okay, so we'll have line A, line B, line C, line D. And those are regular ratios. Later on, we'll talk about ratios where you talk about lines to triangles, or lines to circles, or triangles to circles, or something else like that. That's a mixed ratio. We don't want any of those yet. We got enough time. We got a tough enough time as it is with just the regular ratios. So, a regular ratio involves lines, or nothing but triangles. Let's say you're showing a ratio between 4 triangles, or 4 circles, or 4 rectangles, or 4 spheres, or 4 cubes. Okay? But all of them are cubes. They're all triangles. They're all rectangles, so on and so forth. That's the whole point of the ratio. We're talking about a ratio in which only one thing is involved. Whether it be lines, circles, triangles, whatever, it's all the same thing. So if we had 4 lines here, say we had 1, 2, 3, 4, we had 4 lines here, then we'd have a regular ratio. But if you have 2 lines and 2 triangles, you have a mixed ratio. And we don't want that for Euclid Book 5. In Euclid Book 6, we'll cover that. Alright. I will tell you more in the next video, so stay tuned.